Okay, then question 13 in here. Yep. Question 13. A curve has an equation of y equals 8 over x minus x plus 3x squared. Okay, find the equation of the tangent and the normal to the curve at the point when x equals 2. Okay, straight off, when x equals 2, y equals 8 over 2 minus 2 plus 3 2 squared. Okay, so that is 4 minus 2, 4 plus 12. That 10, 14. Okay, so we're talking about point 2, 14. Okay, dy by dx, the differentiation of this, okay, is going to be, so that's x to the minus 1, so we end up with minus 8, x to the minus 2, minus 1 for the minus x, plus 6x. Okay, so for the equation of the tangent, I am going to need the slope when x equals 2. So dy by dx is equal to minus 8 times 2 to the minus 2 minus 1 plus 6 times 2. Okay. 2 times 2 is 4, minus 8 divided by 4 is minus 2, minus 1 plus 12. 12 minus 3 is 9. Okay, so we've got a slope of 9. So the start of our equation for the tangent at this point is y equals 9x plus c, and now we can put in a point here which is 2 and 14, so we have 14 equals 9 times 2 plus c, 14 minus 18, 2 times 9, 18, bring to the other side is c, so that's minus 4 equals c. So the equation of the tangent is equal to y equals 9x minus 4. The normal will have a gradient of the inverse of 9, which is 1/9, and also a negative. Okay, so we start with y equals minus 1/9 x plus c. We can then put the 214 coordinate into it because it crosses at that point. So we have 14 is equal to minus 1/9 times 2 plus c. So we've got 14 plus 2/9 equals c. 14 and 2/9. Don't see why I can't leave it as 14 and 2/9 equals c, giving us the normal equal to y equals minus 1/9 x, and I'm going to just do this as 14 times 9, which is 126, plus the 2, 128, plus 128 over 9, and to finish it up, to make it neater, I'm going to write it as 9y equals 128 minus x. Okay. That was question 13, now question 14. Okay, Question 14. A curve has an equation of y. No, the norm of a curve is 2x the correct question. Right, so the equation of the curve is 2y equals 3x cubed minus 7x squared plus 4x. Okay, normal to the curve at the point 0, 0 and 1, 0 meet at the point n. Find the coordinates of n. Okay, so we have points 0, 0 and we have 1, 0. And what they're saying is at this curve we have normals going through these points and they meet at a point n. Okay, would be nice to get a visualization of this. Okay, so let's see if we can do that. All right. Okay, so with a web page open, let's look at Desmos so that we can have a little look at this graph to get an idea of what it looks like. All right, so we've got 2y equals 3x to the power 3 minus 7x squared, 7x squared plus 4x. Okay, we then have points 0, 0, okay, which they have called point O, which is just the origin, and we also have point 1, 0, which they have called A. Here we are. Okay, so the tangent is going to come through here, and it's going to come through here, and so we're looking at normal of this one cuts across here, and the normal of this one cuts across here. So we're looking at an intersection down here in this bottom right quadrant. Okay, so let's just sketch that out in terms of what we've got on here. So put it in. Okay, there we are. So the tangent comes through here, and the tangent comes through here, and the normals are at 90 degrees. The normal is at 90 degrees. So this is what our final goal is going to be, something around the region of about 0.5 and minus 0.5. So how are we going to do this? First off, we're going to rearrange this equation, and we're going to say it's 3 over 2x cubed, just give rid of the 2 on it, minus 7 over 2x squared plus 2x. Okay, and then we're going to find dy by dx, and that's going to be 3 times that, which is going to be 9 over 2x squared minus 14 over 2, so that's just going to become 7x plus 2. Okay, now we can find the slope of the line. So the slope at 0, 0 is going to equal 9 over 2 times 0 squared minus 7 times 0 plus 2, which is 2, and we can also do the slope at 1, 0, which will equal 9 over 2 times 1 squared minus 7 times 1 plus 2. So we've got 4.5 plus, sorry, take away 7 plus 2, which is minus a half. Okay, so slope of normal is equal to minus 1/2 because it's the inverse of that one and the negative, and the slope of the normal here will be 2. Okay. Strange. Right then. With that done, we can go through this and we can say that y equals minus a half x plus c is going through 0, 0, so 0 equals minus a half times 0. So c equals 0. Okay, that should be the c. On this side, we have y equals 2x plus c. Y is a 0 equals 2 times 1 plus c, so minus 2 equals c. So over here we have y equals minus a half x, and over here we have y equals 2x minus 2. Last thing to do, decide where they intersect. So since we've got y equals, we can say that minus a half x equals 2x minus 2, so 2 equals 2.5 x, and so 2 divided by 2.5 is 4/5. And so finally we can substitute it back in here. We can say that y equals minus a half times 4/5, which gives us minus 4/10, which is 2/5. And so the point of intersection, 4/5, comma, minus 2/5. Okay. That was a lot, but it was 7 marks. So with that done, we are now looking at what is the triangle. What is the area of triangle OAN? So just looking back at a picture to get a rough bearing of what we've got going on here. That was O, that was A, this is N. Let's clean that up. So we know the height, we know the distance. Okay, so we can find out where we are. Okay, because that's 1. Okay, let's have a little look. So the triangle is like this, and we've got 0, 0, we've got 1, 0, and then we've got the 4/5, go on minus 2/5. So half the base, which is 1, okay, times the height, which is 2/5, gives us 2 over 10, which gives us 1/5 units squared. Okay. Okay, question 15. Question 15. Curve C has an equation of y equals x cubed minus 2x squared minus 4x minus 1. And it cuts the y-axis at point P. The line L is a line L is a tangent to the curve at P and cuts the curve at the point Q. Show the distance of PQ is 2 root 17. Okay, so again, we have some sort of curve here, and it cuts through at -1. Okay, let's have a look at it through Desmos again, just to get an idea. Okay, don't need these 2 points. And we have got x to the power 3 minus 2x squared minus 4x minus 1. Okay. Something like that. So what did it say to us? And cuts the y-axis at point P. So this is point P. Okay. The line L is a tangent to the curve at point P. There it is. It cuts there at a nice tangent, line L, and cuts the curve at point Q. Now, just looking back at your Desmos picture, if we were to do that, it's going to come down and it's going to cut all the way down there, isn't it? So this here is your point Q. Okay. Show that the distance of PQ is 2 root 7. Okay, let's start with finding out what the equation of L is. Okay, so we're going to do that by finding the slope at x equals 0 minus 1. So start with differentiating the equation. 3x squared minus 4x minus 4, and then when x is equal to 0, because I'm on the y-axis, okay, we end up with 3 times 0 squared minus 4, 0, minus 4, and so the slope of L is equal to minus 4. Y equals minus 4x plus c, and I know it sits on or goes through the point 0 minus 1, giving me an equation of minus 1 equals minus 4 times 0 plus c, minus 1 equals c, so L is y equals minus 4x minus 1. Okay, now what I want to do is decide when that is equal to PQ, so that I've got the intersection point. So the line C can be written as x cubed minus 2x squared minus 4x minus 1. And I want to know when it's equal to this line, which is minus 4x minus 1. X cubed minus 2x squared minus, that becomes a plus, so that disappears, is equal to 0. Okay, so they both cancel that out. Let's do a bit of factorization here. So x squared is equal to x minus 2 equals 0. So we've got x is equal to 0, and we've got x is equal to 2, which makes sense because we know it's equal just at the point of 0 where it touches on the tangent, and then moving along a bit when x equals 2. Okay, so that coordinate, then we can use the line just because it's simpler, which was minus 4x minus 1. We can say that y is equal to minus 4 times 2 minus 1 minus 8 minus 9. Y equals minus 9. So we have the point of 2 minus 9. Okay. So looking back at our picture then, we have the coordinates like this. This is line L, and it's at minus 1, 0, and then it's cutting down here at 2 minus 9. So we've got a distance of 2 between here and a distance of 8 between here. So the length of the is going to be PQ is going to be the square root of 8 squared plus 2 squared, square root 8 squared plus 2 squared, which is 2 root 17, which is what we needed to show us.